Hello and welcome to another episode of Envisioneering Exchange, the podcast where industry leaders discuss the most important topics in building and urban efficiency. I'm your host, John Sheff, Danfoss's Director of Public and Industry Affairs. Before we get started, I just want to let you know you can subscribe to our show on Apple Podcasts, Spotify, SoundCloud, or wherever you get your podcasts. Today's topic is the future of cooling, and I am thrilled to be joined by my guest, Vince Canino, CEO of Smart Inc. Now, last year, Vince was elevated to CEO of Smart after the announcement of the company's joint venture with Tika, China's leading high-efficiency ventilation solutions company. And Smart is a global leader in oil-free technology, and the new joint venture plans to accelerate development of comprehensive oil-free solutions in key markets like cities, data centers, pharmaceuticals, manufacturing, and healthcare. I'd also like to note that Smart and Danfoss are very close partners as Smart grew out of a joint venture between Danfoss and what was Turbocore oil-free compressors. Now Turbocore is part of Danfoss and a key supplier to Smart's oil-free technology. Vince, thanks for joining us. Why don't you tell us a bit about yourself and your new role within the company?
Thanks, John. Glad to be here. First part of my career was focused in power generation. Starting out with General Electric and then starting a company where we built, owned, and operated cogen plants and district cooling loops. And then the second part of my career has been mainly focused in HVAC, where I spent some time with Trane and then came over to Smart, actually 6 years ago, a little over 6 years ago, so in 2014. So as you know, John, Smart is a global company focused on oil-free technology. That's all we do, which is why our relationship with Danfoss is so important, but we'll get into that maybe a little bit later. Roger Richmond-Smith, co-founder of Turbocore and also the founder of Smart, as he was building Smart over the years, recognizing that a global footprint was really key to driving oil-free technology around the world. You know, we looked around and felt like, China is a very big market, as we all know, and it's just, I would say, in its teething of transitioning to energy efficiency focus and life cycle cost, and really, trying to, play its part in the world in terms of lowering greenhouse gases and things like that. And as you all probably know, and a lot of people know if they've ever tried to do business in China, it's not very easy, and you need strong partners. And Tika turned out to be one of those partners for us. They're very strong in China. And they were only focused in China, so they needed a strong partner who had a global presence and a global footprint. So it really made a lot of sense for us to join forces. When you take a look at our company's philosophies and our core values between the two companies, they align very, very well. And then on the product side, there was very little overlap. So we do the things that Tika has been wanting to do, and Tika does the things that we think can help us also put together, not just sell chillers, but also sell a solution to our customers. Because a lot of times, as much as they may be focused on the highest efficiency chiller, at the end of the day, they need a system. And it really is about system efficiency and other products that go into that integration of that system. So it really makes a lot of sense for us to be together.
Yeah, it sounds like a great fit. And you're right, access to the market in China. And as this market evolves and it kind of grows and they're getting more energy efficient and learning about this technology, I think it's going to be so key. Now, like you mentioned, the oil-free chiller technology is gaining market share around the world. Why is this technology so important, especially, like you mentioned, given new climate commitments we're seeing from different countries, from companies? And even in the U.S., where, the outcomes of the elections that we just saw, we could see more. We'll certainly see things like Kigali brought to the Senate floor and most likely signed, and some more climate-focused policies. What about this technology is going to help in that transition?
Well, I think it helps a tremendous amount. And I would go back to even my Trane days when some of our folks in the performance contracting business obviously are looking for energy efficiency to do these types of projects. And the Turbocore technology made a lot of sense. If you look around the world, the consciousness of lowering greenhouse gases and reducing our carbon footprint is becoming, on the forefront of everybody's mind. I think it is important. People can argue back and forth on climate change and those kinds of things. But at the end of the day, The right thing to do is to try to save energy. More and more we build products that are better in terms of energy efficiency, but we tend to use a lot more products. Years ago, I used to do this guest lecture at a university up in Washington, and I had this slide that showed in the 60s what people had in terms of the efficiency of their refrigerator and a television and what it is today. And even though the efficiencies are 50% better, we're using more devices, right? We now have laptops, cell phones, and things like that. So even though we continue to make our products more efficient, if we're not also conscious about how we're using that energy, we're going to continue to, not lower the greenhouse gases that are out there and help the climate. So when we look at this technology, a lot of this stuff, may have a 10% incremental improvement. But when you look at this technology and you can see a 20 and sometimes even 30% improvement in energy efficiency, that makes a big difference. It takes a big bite of the apple, if you will. So we truly believe that this is the way to go. We believe that this technology is a very important role in how we're going to reduce greenhouse gases and carbon footprint.
And yeah, it's not just the efficiency, but I think the sustained performance over a long period of time where we can depend on these increases in efficiency, reduction in energy use is really a less understood benefit of the technology, but really important.
John, it really is. And, one of the things that we embarked on, right away when I joined Smart was to really try to create an awareness with our customer base around life cycle cost. And what does that mean? Because I would tell you, in my experience in different meetings that I've had over the years with different types of customers, and we talk about total cost of ownership. Energy is easy. I can do the energy savings calculations, but a lot of the other key elements that customers are missing when they buy a chiller or even build a central plant for that matter, they're not looking at every single element that goes into how that asset operates, right? And degradation or sustainability, as you're saying, but it's really the degradation of the equipment is so important. And that's something that we take our customers through in what we call our TCOM model, which is total cost of ownership. But, in addition to the energy savings and the preventative maintenance savings, because you don't have an oil system that you have to maintain, but there's also major maintenance on that equipment. The oil-based machines those compressors have to go through an overhaul, and they're pretty expensive and time-consuming. There's also oil heaters and oil pumps that are consuming energy that aren't accounted for always in the chiller efficiency. And then last and most important is the effects of oil in terms of how it affects the capacity of a machine over time and how it affects the machine's efficiency over time. There are a number of different studies that have been done. I think there's an ASHRAE 601 paper. There was another study in Qingdao out of China that was done. And there's a few others. But, that's the other real important element that our customer base needs to fully understand is that not only do you get this energy savings on day one, but you get it in year 20. And I know we've been working closely with Danfoss on removing some compressors that have been in operation for over 10 years to do studies on the degradation of those compressors. And the findings are very compelling. There's very, very little. I mean, you're talking about decimal place degradation. So that's the part that we've got to get our customers more comfortable with and better educated around, because there's another step to this, is that once we get them to understand the sustainability of this technology, and they're not going to have that degradation over time, we also have to do continuous commissioning, because buildings, they don't operate at a constant speed or a constant level, right? They're going to change. They go up, they go down. They have different needs during the day and in the evenings. And over time, things fall out of calibration. So this whole talk, and it's been a long talk for many, many years about continuous commissioning. I don't think anybody's fully figured it out. But that's another key area of that sustainability element that we need to be chasing, because all of that together helps us drive the true energy reduction in a building and make a better commitment to lowering our greenhouse gases.
Yeah, and I think that's a really good segue into, what's going on right now with buildings in light of COVID in light of fluctuating occupancies, the need for greater ventilation and greater airflow. And just, I think HVAC is going to be in the spotlight here as we go into the future and looking at how we make these workplaces safer for people to come back to work. I mean, what are you seeing in different areas of the world when it comes to, adapting these buildings to really a new way of working?
Yeah, it's a big one. I mean, we're seeing this in the airline industry and what they're doing in terms of how they're cleaning airplanes and how they're doing filtration. And the reason why we know a little bit about this is, again, because of our partnership with Tika, who happens to own an air filtration manufacturer called Mayer. We're actually looking at bringing that product here to North America. But the filters that we're talking about are not just your everyday filters. These are the HEPA filters. These are the ones that are going to scrub the air and try to remove the virus or any type of virus, for that matter. So we see that as a really important product. And even though Smart itself doesn't manufacture air handlers, we do have a distribution channel and we have access to help other customers get the best products possible in order to combat that. I do see us down the road bringing some Tika air handling products, and I think very focused, especially in the healthcare industry to start with this high-end filtration to make sure that we're cleaning up the air in these buildings so that people are safer. But definitely, we're going to see a transition for sure. I think some companies might be a little bit more bullish on it than others when you look at the commercial space. But I think definitely the healthcare space is going to be very, very focused on this. I think the airline industry is going to be very focused on this. I think the commercial building space is going to do the typical economic analysis and say, well, how much do I really need? And what do I have to really spend in order to get that? And they'll try to find that right balance. But it's going to be a big deal, no doubt about it.
Yeah, and I just think that when we look at these new HEPA filters, increasing outdoor airflow into the buildings, it's needed to make people safe, but it is also going to increase energy costs and HVAC costs because systems are going to have to run more. They're going to have to run harder. And I just think that having a true variable speed system like, Smart's oil-free technology is going to be a key differentiator, being able to ramp up capacity when buildings are full, ramp down when they're not full to accommodate new ways of working and to accommodate these new filtration systems and really be able to save as much energy as possible is going to be at a premium in the future, I think.
Oh, absolutely. That's another part that a lot of people don't always understand. And I find the whole chilled water design space a very interesting space. It's very much like utilities if you think about it. You have to design for the worst case scenario, right? Utilities always have to have a 15% spinning reserve in order to not have any brownouts or blackouts, right? So that at any point in time, the consumption in the hottest day is always going to be, they're going to be able to generate enough power so that they don't take the grid down. Well, in a building, air conditioning is the same thing. They design it for the hottest day potential so that you don't take the building down and you don't send people home, because if you send people home, you lose a lot of money. But that becomes a very inefficient design with the older technology, because at those part loads, which is where they typically run, they're much worse on efficiency. And this is where our technology really plays well, because we love part load. Part load is where we're the most efficient. And to your point, not every building runs the same all day long, all year long. Weather has a big play in this, and as well as the number of people that are in the building and the equipment that they're using. And so absolutely true that you have to have technology that can respond quickly to the changing environments and do it as efficiently as possible. And that's why we're totally dedicated to just oil-free technology, because the bottom line is, when you look at that total cost of ownership, it's the most efficient and the most beneficial when you're looking at owning an asset for over 20 years.
Mm-hmm. Yeah, and I think we're going to see, more and more oil-free. We're going to see more and more totally electrified systems. Particularly, there's a lot of talk of electrification in North America. We see governments, particularly at the state and local level, having these natural gas bans, building emissions laws. There's been pushback at the state level against local natural gas bans. There's just a lot of activity here, and it seems a little scattered shot. But how does Smart view kind of the growing demand for heat pumps and other electrification technologies in North America? And, follow on, what are we seeing in other places like China?
Sure. And I would say probably Europe is leading the way when it comes to things like this. We exist because we truly believe in revolutionizing the HVAC space. And we do that with revolutionary technology and the integration of that technology. And at the end of the day, we want to leave the planet a better place for our kids and the next generations to come, right? So with that, we always have that in the back of our mind. And when we see things like this, we're going to ask why. And it's the reality of an idea versus an ideal. And so, we could see the market and where it's headed. And we're certainly developing products, and we have products that can meet some of those demands. Obviously, we are looking to Danfoss with some of their new technology and the new compressors. We got to continue to push them to continue to develop their high lift compressors so that we can achieve higher water temperatures. Because if the world is headed to electrification and trying to get rid of all of these boilers in buildings, you're going to need two things. You're going to need a technology that can get to those water temperatures that the buildings need. And this isn't just comfort cooling, right? This is also some of the other things like process heating and so forth. But in addition to that, we're going to have to do it in a more efficient way. And I don't just mean kilowatt hour consumption. What I'm talking about is demand. Because if we think about this, and let's take New York City, for example. I don't want to call it a storm, but there is a storm brewing there. They had passed Local Law 97. And so their goal in New York City is to get every building off of fossil fuels. Now, that's a grand idea. Ideally, that makes a lot of sense. Although, you have to ask yourself the question, you've got to get those electrons from somewhere, and you're getting them from a power plant that's maybe 50%, 60% efficient at best. And then you've got to bring those electrons across the transmission and distribution system that's going to have losses of 12 to 20%. So is that more efficient than a 98, 99% efficient natural gas-fired boiler? You can ask those questions, and those are the things that we'll continue to ask too, because again, we have to see where the market is going, and we're going to develop products for that market, but we have to see where the end game is and what makes the most sense, and what are the products we should be developing that kind of bring us there. It's kind of like, for those of you that have been around a while, maybe the younger generation doesn't know about the beta versus the VCR, right? But that was a big play back then, right? Which one was going to win? And that's part of what we've got to do at Smart is we're watching this and saying, should we take the hybrid car approach? Should we have a balance of electrification plus, or go all in on electrification? But if you look at New York City, the biggest challenge they're going to have is their electrical infrastructure may not be able to handle all of that. So you've got one of two choices. One choice is you got to try to put a boatload of renewable energy on those buildings in order to support this new heat pump application, if you will, because, a lot of these buildings are tapped out when it comes to electrical service. So you got to take a look at that. And if they can't do that, then maybe a hybrid model makes sense, where you put in the heat pump and the heat pump takes 80 to 90% of the heat load. And then you either put in smaller boilers or you part load those boilers if they're efficient enough and don't pollute as much in order to hit those cold climate type days in the wintertime, in your coldest days. But at the end of the day, we're not sure where this is all going to end up. That's why we look to Europe, because typically Europe tends to be ahead of everybody else. When you look at Europe and what they did with anaerobic digesters and what they've done with solar and wind, they led the world in a sense of adopting to those technologies first. And they've learned some things along the way. And I think that's part of what we've got to do. And as I look at Europe now, they're also pushing hard on electrification. And so we're going to keep an eye on that as well. But it's going to be an interesting development. And I don't think there's an easy solution. But I think at the end of the day, we're ready for it. I think we have some products today that can meet the needs. But we're also going to have to push harder on Danfoss to develop the future technology in order to capture all of it, right? Because that's going to be the important part of where this ends up.
Yeah, I think we're excited about it too. And we've talked a lot on this show about Local Law 97 and its impacts. And I think you're right. They want to put solar and wind on every building, and they want to have a lot of microgrids. And it's going to be interesting to see how it plays out, because there are a lot of buildings in New York, big multifamily, big commercial, that have multiple giant boilers in the basement,
right,
in the machine rooms, and getting those out and getting heat pumps in. It's going to be really interesting to see how that plays out. And it's going to take a long time.
It is. And I agree that there's a lot of old boilers in the basements in New York City, and they're inefficient and they have to go. And those should be the first opportunities that people are looking hard at.
Well, they spent a lot of time transitioning from heating oil to natural gas there.
Exactly. And if you think about it, right, if you're a building owner, the economics also play into this. And coming from the power generation world, I remember when we first started playing around with solar and anaerobic digesters, and they really great ideas, but economically there was still a stretch. And so often we get customers say, yeah, I'm going to do it. And then when you get down to the final numbers and the payback just isn't there for them, they don't do it. And so that's my only fear, is that we're going to be looking at this. But I also believe that New York City, the economics can work between the cost of natural gas and the cost of the Con Ed steam loop. There's things that electrification just makes sense. But now you've got to tackle the other technical challenges that come along with that, which is, how are you going to power these things? And there's only so much solar that you can put on a building. There's only so many, little wind turbines that you can put on that building. So you're going to have to find a self-generating or a renewable energy source a lot of times. But here's where we're excited, because I think, with this turbo core technology and the modularity, we can get equipment into those types of tight spaces in buildings in New York, whether it's, up on the 27th floor or down in the basement. We have the ability to bring our equipment in much smaller pieces. We've developed a 400-ton water-cooled chiller module. And so this thing can come in on a freight elevator, and you could put 1,200 tons in the basement of a building in New York City if you have a freight elevator.
That's amazing.
So that's the really cool thing about our technology that we use with TurboCore, is it gives us that flexibility. And I think that's what you're going to have with heat pumps, quite honestly, because I don't think there's going to be one set of heat pump designs that are going to address all the different buildings that you have in New York City that are, some are hundreds of years old to 10 years old, and they all operate differently. They all have different ways to get access. They all have different challenges. So you're going to need equipment that's got flexibility for sure.
Mm-hmm. And one last thing I'll say about New York is that I think heat recovery is going to be play a big role somehow, because I think there's a lot of energy out there that's being wasted. And if we can figure out a way to use that, I think it could go a long way.
Yeah. I really like the idea of this ambient loop concept, which I think, a city like New York could do. And if let's just play around with the idea. You take that Con Ed steam line, and if you were able to use that asset and that infrastructure and flow water around and do exactly what you said, and you do heat recovery in every single building, and it's adding heat to this distribution loop, maybe everybody can get more efficient and actually more cost effective in the city or in a particular borough or whatever to take advantage of something like that. But I think you hit the nail on the head. And this is something that we think about a lot at Smart, because, we're really not a chiller manufacturer, although that's what we do. We're really an energy company and an energy-minded company. And our goal is to look at, there's really two aspects to lowering greenhouse gas emissions, right? One is how you generate the energy, and the other is how you save or conserve the energy. And right now, a lot of our products are focused around conserving energy, but we are doing a bit around renewable energy and how to integrate solar and wind and fuel cells into our chiller technology so that they can be, in a sense, a little microgrid. We also are looking at those types of things so that as a system holistically, at the end of the day, we're probably going to go back to microgrids. We call them microgrids, but distributed generation and DC power. And we feel very strongly about that. because again, our transmission and distribution system is very old. It's aging. It costs anywhere from $1 million to $5 million a mile to upgrade. You can't continue to build more fossil fuel power plants, right? I think coal's going to go away. It's gotten a lot cleaner, and it's going to continue to get cleaner, and it's still an important aspect. But if you look at some of the numbers, coal has shrunk quite a bit. Natural gas powered plants have gone up. They've replaced those coal plants. Renewable energy has certainly taken a bite, but it really hasn't been a big enough bite. But it's hard, and it's not as economical yet. And over time, we're going to do that. But at the end of the day, we have to look at how do we look at waste to energy? How do we take heat sources and use them more? How do we minimize how we waste, right? But also, how do we self-generate? Because again, we can't rely on these big power plants to provide all of this energy anymore. So we've got to find that way to make it more of a distributed generation play in a building. And quite frankly, I think when you start looking at LED lighting and all of these things, DC power in a whole building might make sense. I mean, the reason why Edison lost the war years ago, right, was he couldn't distribute DC across long distance. And that's why when Tesla came up with alternating current, it made a whole lot of sense to wheel power from Niagara Falls all the way down to New York City. But now we're coming back around, and I truly do think that this microgrid and distributed generation is really where we're going to have to go in the future. And at the end of the day, we got to balance all of this. I don't think there's going to be one solution, quite frankly.
Yeah, I think you're right about that. Now, we've got to wrap up in just a minute, but you hit on the kind of the future and how you see things, and it sounded like you were talking about North America. Do you see the same pattern evolving in other markets, Europe and Asia, or are we going to see different solutions for different markets, and even within those markets, different solutions?
Oh, for sure. Like I said, I like to follow Europe because Europe tends to lead when it comes to being green and these types of things, right? And the Europe infrastructure is much older. And so those constraints are really going to help us understand how to better do things in other countries and other continents. But I see this definitely heating up in Europe in terms of electrification and heat pumps and where we go with distributed generation and microgrids. And and every country is going to be a little bit different, and they're going to be at a little bit different pace, if you will. And some of that will be based on their natural resources, and some of it will be based on their infrastructure constraints. But holistically, I see Europe leading the way. I see North America following. China is going to keep an eye on it, but China is still in a very big growth mode. So they're still learning how to conserve energy and how to get off of coal. I mean, just think about 5 years ago or so, or even longer, they were burning coal in their houses to heat and to cook. And so now they're moving the homes off of the use of coal. Building owners, they weren't worried about maintenance. They could buy things so cheaply that they would just buy it and not maintain it, and in 5 years, replace it again. And now we're starting to see this shift towards life cycle cost and asset ownership, and that, I don't want to go through this buying process every 5 or 7 years and allow my equipment to get so inefficient. So they're starting to become more conscious of the asset ownership, a part of the equation. There was a great study done by, I think, Jacobs Engineering and some folks out of Stanford University, where they look at first cost versus basically CapEx versus OpEx. And, 75% of the focus and the effort is put into that first cost CapEx side when somebody's building a building. And nobody's really thinking about the operational side of that. But the building's going to last 50 years, sometimes even 100 years. So, what you do up front affects the life of that building. And sometimes you have to spend a little bit more in order to make that OpEx more efficient and more effective. And I think there's got to be that shift. And so when you look at the world, I think Europe is definitely leading that because they've obviously been around longer and they've got an older infrastructure that they have challenges that they're trying to deal with. I think North America is going to be right after that. I think the Asian market is going to be very, very intriguing. Places like Thailand are going to be taking hard looks at this. We see Singapore. They're leading the way when it comes to energy efficiency and some of the programs that they have. and how they track a building's energy efficiency when it comes to HVAC. And if they start to drift off of those guidelines or those requirements, they'll force them to upgrade their HVAC system in order to get back into the energy efficiency guidelines that they have. So we're going to see more and more of that. And I do think that different countries are going to be looking at these quite differently because, again, where they are on the spectrum. But I think the awareness is there.
Yeah, and I think that's the key point, is that people are really starting to look at this very closely now and all over the world. Well, I think that's a great way to end it, Vince. I really want to thank you for joining us, and that's going to do it for this episode of the Envisioneering Exchange. Again, I'd like to thank my guest, Vince Canino, CEO of SMART, and don't forget to subscribe to Envisioneering Exchange on Apple Podcasts, Spotify, SoundCloud, or wherever it is you listen to your podcast. And lastly, if you enjoyed this episode, please don't forget to rate, review, and share with your network. Again, my name is John Sheff, Director of Public and Industry Affairs at Danfoss, and thanks for listening. We'll talk to you next time.
This podcast is for information purposes only. The views, information, or opinions expressed during the Envisioneering Exchange podcast series are solely those of the individuals involved and not necessarily represent those of Danfoss LLC and its employees. Danfoss LLC is not responsible and does not verify for accuracy any of the information contained in the podcast series available for listening on this site. This podcast series does not constitute professional advice or services. This podcast, including Danfoss LLC and the producers, disclaim responsibility from any possible adverse effects of information contained herein. Opinions of guests are their own, and Danfoss LLC in this podcast does not endorse or accept responsibility of statements made by guests. This podcast does not make any representations or warranties about the guest qualifications or credibility. Individuals on this podcast may have a direct or indirect financial interest in products or services referred to herein. This podcast is available for private, non-commercial use only. You may not edit, modify, or redistribute this podcast. The developers of the Envisioneering Exchange podcast site assume no liability for any activities in connection with this podcast or for use of this podcast in connection with any other website, computer, or playing device.